Let's move on now to section 1.2, which is going to be sketching graphs of linear equations. So the first thing I want to do is kind of review some algebra stuff, beginning algebra review stuff that you're supposed to know, kind of, and here's a hint, it might show up on your final exam. Okay, so let's look at this. We're supposed to solve this equation right here. So I'm going to bring it up so you all can see it. Okay, so let's look here. Now if you look at the left-hand side, you've got this 3 times 2x minus 1 equals 4 times 2x plus 3. And anybody who's ever been in a beginning algebra class learns that you have to distribute. You have to do 3 times the 2, which makes 6x in this case, and 3 times the negative 1 makes minus 3. Then you have your equals, and then you have 4 times 2, which is 8x, plus 4 times 3, which is 12 minus 5x. Now, to clean up your life, it would help if you combine some like terms over here, because the 8x take away 5x. These two pieces right here combine to make 3x plus 12. All right, now at this point, what you want to do is you want to get the 3x over to the other side, right? You want to combine the 3x with that 6x. So I'm going to minus 3x from both sides. Hold on one second. And then while we're at it, let's add the 3 to both sides. So I'm going to minus the 3x, and I'm going to add the 3. Now, why am I doing all of this? In beginning algebra, they kind of separate it into 2 steps, and you can if you'd like, but we're in intermediate algebra now, so let's kind of combine some things together. So what's my plan here? What's my goal? Well, I'm trying to make it so that all the numbers are on one side and all the variables are on the other side, right? That's my purpose. Okay, so then these two parts are going to go away, because if you have a negative 3 and you add 3 to it, it goes away and becomes 0, right? And then if you have 3x and you take away 3x, that all disappears, right? Okay, so what's that leave you with? On the left-hand side, you've got this 6x business and this minus 3x, which is going to mean you're going to be minus 3x equals. And then over on the right-hand side, you've got 12 plus 3, which is 15. And then all you have to do is divide by 3, right? Or it's negative 3. So you divide everything on the left by negative 3 because you want that negative 3 to get out of there. And then you do it again to the right. Now, what was your purpose in doing that? Well, it allows you right here to cancel that, divide it. Canceling is a terrible word, but you're dividing it away, right? And then over here, so on the left you're left with x, and on the right you've got negative 5. So that's your answer right there, negative 5. Done. All right, now what about the second part? What about this thing with the fractions? Isn't that miserable? Well, yeah, kind of. Okay, so the one thing you want to notice when you look at this is your LCD, your least common denominator, is 12, right? So 12 is divisible by both 3 and 4. And you could do 24, but 24 isn't the smallest one. It pays to go with the smallest one. All right, so see, just thought I'd clean that up a little bit. Now, what are we going to do over here on the right with that LCD? Well, what you do is you multiply everything by that LCD. So we said the LCD was 12, so you put it 12 over 1. Now I know what you're thinking. You're thinking, Alana, that doesn't make anything easier. Oh, but it does. I swear. Trust me. Okay, so if you take 12 over 1 times a third minus 12 over 1 times times positive a fourth, because you already have the times part, the minus part right in there, and then equals 2 over 3 times 12 over 1. Okay. Now, how is this helpful? Well, let's look at this. 3 and 12. 12 is in the numerator, 3 is in the denominator. Now, 3 goes into 12 4 times. So that leaves you 4x for that first term. Right here, this part right here becomes 4x. Minus, now 4 goes into 12 3 times. So it's going to be 3 for that one. Right? So it's essentially 12 over 4. And now what about the back one? That's the harder one. 3 goes into 12 4 times, right? So 3 goes into 12. Let me put that in there. Oops, it didn't like me there. There we go. And then that would leave you 4, right? So 3 and 12 cross off and leaves you 4. 2 times 4 makes 8. And then at this point, you just add 3 to both sides, which gives you 11, right? Add 3, and then divide by 4. So x is equal to 11 over 4. There's your final result. Awesome. All right, we're done with that one. All right, now what about the next part? Right, so again, more beginning algebra review, if you will. So more stuff that you're technically supposed to know before you got into 131. So let's see if it works out for us. So the first thing they want you to do is they want you to take this formula, d equals rt, which if you've ever been in an algebra class, you've learned is distance equals rate times time, right? How far you go is equal to how fast you're moving, your rate times how long you move for it, right? And they want you to solve it for t. They want the t variable by itself. So you want to ask yourself, okay, if I want t by itself, I want to get rid of the r, obviously. That operation right there in between the r and the t is multiplication. So your plan is to divide by r. But if you do it to the right-hand side, you got to do it to the left-hand side to keep everything fair and balanced, right? Not to quote any news organizations, but all right. So then, there we go. So then you get d over r is equal to t. And in some class somewhere, hopefully you learned that equal signs, equations, are commutative. Namely, you can flip their order. You can have t on the right, you can have t on the left. It doesn't really matter to me which way you write it. So if you left it like this, that's totally fine. But if you are the type of person that likes, the letter on the left equals all the stuff on the right, then this is how to do it. So there you go. You've now solved that equation for t. Now you got to do the same sort of idea here with this formula, which again is probably a formula that's familiar to you if you've ever been in a math class. It's for perimeter, right? The perimeter of a rectangle in particular. So you're supposed to solve this for L. So we want to get L by itself. Now, a lot of students think, oh, I should divide by 2 first. Yeah, not really. It's because that adding in there kind of makes things tricky. So we'd be better off subtracting 2w from both sides, right? And of course, if you do it to the left, you got to do it to the right. Keep everything copacetic. So what's going to happen? Over here, these are going to disappear because if you have 2w and you take away 2w, it's gone. But on the left-hand side, you have p minus 2w. They're not like terms. They have different variables in them. So you can't actually simplify that. You can't combine it together. You just have to write p minus 2w equals 2l. Now you divide both sides by 2 to get the 2 out of there, right? Because this then will go away, like that. Okay, so that leaves you L is equal to, I'm just flip-flopping the order here, but p minus 2w over 2. Now that is totally okay with me as an answer. If I was having you do this, that would be fine. There is another way to do it. Let me write it up. It's 1/2 p, or if you like, p over 2. So you could say, hey, that's p over 2 minus, oops, no fraction, w. So let me see if I can get you to see it. In front of the p, there's a number 1. Okay, so maybe I like this better. It's 1 over 2 p minus 2 over 2 w. right? So there's 2 over 2 on the back numbers, and there's 1 because there's no number in front of that p, so that means there's a 1 there because 1 times p makes p. So it's 1 over 2p minus 2 over 2w, which would be 1 over 2p minus w. So I don't really mind the first thing that we boxed. This one over here, p minus 2w over 2 is totally fine with me for an answer. It's possible my math lab might want you to simplify it a little bit more for some reason, so they might like the 1/2 p minus w. So be able to do kind of both. But either one of them is fine for me. Once you have the L by itself, it's all good. Okay, we're all done with that page. Now let's look at the next example. It says to show that when x equals 5 and y equals 7, that when x equals 5, then y equals 7 for this equation. So you can do this a couple ways, but what we'll do is we'll take that equation, and it's said to say when x was 5, right? So we'll say y equals 2 times 5 minus 3. So you take the x away and you put 5 in instead. Okay, well, what is that? That's y is equal to 10 minus 3, which last time I looked is 7. And we showed, in fact, what we were trying to show, that when x was 5, when we put in 5 for x, we get 7 out for y. All done. Now, let's look at this definition right here. It says that an ordered pair AB, remember that means a point, right? The coordinates for that point, A comma B, is a solution of an equation in terms of x and y if the equation becomes a true statement when A is substituted for x and B is substituted for y. We say that AB satisfies the equation. So in other words, let me put this one up here. The point 5 comma 7, that's our ordered pair, is a solution of the equation y is equal to 2x minus 3. Right? There we go. 5, 7 is the solution of y equals 2x minus 3. Okay. All right. So now let's look here at this graph. Our job is to figure out which pairs, which ordered pairs, i.e. which points, right? Because ordered pair is a fancy word for points. Matter of fact, I'll put that right here. Points satisfy the equation. All right, to satisfy an equation for a graph like this means that it's actually going to be on that line, right? So which ones satisfy it? Let's see. B, C, and F. B, C, and F are on that line, so they would satisfy the equation. A, E, and D do not satisfy the equation because they're not on the graph of the line. If it satisfies it, it's going to be on the graph of that line. All right, let's move on to the next thing. How about graphing lines? Now, this is the first of 2 methods we're going to use for graphing lines. This is the one that we do by plotting points. So you create a table of ordered pair solutions of the equations by substituting values, and you plot those points. Hold on, let me make a little table here real quick. Okay, so you can put it kind of off on the side. So what we're going to need is we're going to need x values, and we're going to need y values. Okay? Okay, so let's think of some intelligent values to choose here for this graph. We want points that will fit on the graph. And as much as students always want to avoid it, you don't want to avoid the negative numbers. You want to get those too, right? Okay, so I've got -2, -1, 0, 1, 2, 3. And you want to substitute each of these into that equation. So you say to yourself, okay, -2 times 0 plus 6, that's 6. -2 times 1 plus 6, that's 4, and so on. And you can use a calculator to do this. Poof, I even have a calculator. All right, so let's see. Clear. All right, -2, parentheses, -2, that's get you your times, plus 6. Because the negative ones are probably the harder ones for you guys. So you go, okay, that's 10. And then you do it again. -2 times -1 plus 6. Now this is this method. There's lots of other methods, okay? So that's 8, that's 2, that's 0. And then you just plot the points and draw the line. Let me do that by computer. Hold on one sec. And it's a good idea while you make these graphs, when you're plotting them yourself, to kind of plot every single point that fits on the grid. That way it's a perfect graph. Now there's a little bit more to graphing. I'll meet you back here for more info on that next video.